Welcome all to the online lecture series of Mechanical Engineering Materials. Our today's topic is non-ferrous metals and its alloys, and the course outcome is use non-ferrous metals for mechanical components. Now let's start with the unit outcomes. So here are the unit outcomes. First one is describe the properties and applications of given copper alloy. Next one, describe the properties and application of given aluminum alloys. Then describing properties and application of given bearing materials, and finally select relevant non-ferrous material for specified application with just. Now let's look at what are the topic outcomes for today's lecture. Our first outcome is introduction. Here we'll understand what exactly are non-ferrous metals, their examples and their applications. Then we'll find out what are the arbitrary classification of non-ferrous metal. Here the arbitrary classification is nothing but classification based on certain characteristics that we will study in this topic, in this lecture. And finally properties and application of these non-ferrous metals. In this lecture we will only look at non-ferrous metals and their applications. In next lecture we will look at non-ferrous alloy. Okay, now let's start with the introduction. Non-ferrous metals are those which do not contain significant quantity of iron or iron as a base metal. So in our previous lectures we have seen various alloys of iron such as steel, plain carbon steel, cast irons, etc. So in all these metals we have seen that iron is present in a major amount or in a large amount. So these were called as a ferrous metals or ferrous metal alloys. So today we will look into non-ferrous metals, which means the metal which do not have iron or have very small insignificant quantity of iron. These metals possesses low strength at high temperatures, generally suffer from hot shortness, have more shrinkage than ferrous metals. They are utilized in industry due to following advantage. So let's look at what are the advantages of non-ferrous metals. First is high corrosion resistance. So this is very important advantage of non-ferrous metal, because in case of iron alloys, that is steel, cast iron, etc. So we have seen that only stainless steel has a pretty good or very good corrosion resistance, but in case of non-ferrous metals, most of the non-ferrous metals have high corrosion resistance. Next, they are easy to fabricate, which means they are easy to machine, casting, welding, forging and rolling. So with these properties or with these processes, you can give any shape to the non-ferrous metals. You can form any shape or any size of product using this non-ferrous metal because of their easy fabrication. Next is possesses very good thermal and electrical conductivity. So we'll be looking it in our coming slides that how most of the non-ferrous metals are very good thermal as well as electrical conductors. And next is attractive color and low density. So all the non-ferrous, most of non-ferrous metals, we'll look into the example like here copper, aluminium, lead, tin, zinc, nickel. All these have an attractive color, so they have a pretty good luster. They are very attractive to look at, and they also have low density. That means they are lighter as compared to the iron alloys or steel alloys. So as we said earlier, copper, aluminium, tin, lead, zinc and nickel, etc. and their alloys are various non-ferrous metals available to us or available or used in industries. Now let's look at the arbitrary classification of non-ferrous metals. So in first classification, we'll classify the non-ferrous metal upon their density or upon their weight. So first is light metals. So out of various non-ferrous metals, aluminium, magnesium, titanium, beryllium, etc. are the lightest metal. That means they are very light in weight. Next is heavy metals. So copper, zinc, lead, tin. These are the example of heavy non-ferrous metals, while aluminium, magnesium, titanium, beryllium are light non-ferrous metals. Then refractory metals. So refractory, the word refractory means the metals which have high resistance to heat and wear. That means they can undergo processes at very high temperature without any wear or without any abrasion. So examples are tungsten, nickel, molybdenum and chromium. Finally, precious metal. Precious metals are nothing but the metals having that can be that have a high value that are used for making various jewelries, etc. So these are gold, silver, platinum. So gold, silver, platinum are precious metals, which means they are used in jewelry making. Next is, so now let's start off with the example or first type of non-ferrous metal that is most commonly used, which is aluminum. Now let's look at the properties and uses. So in our today's lecture we'll be looking at most commonly used non-ferrous metals, and they will look into their properties as well as their uses or their applications. So let's start with aluminum. Aluminum, like copper, it is also corrosion resistant. So we should know that like copper it is a corrosion resistant. Next, it is a very good conductor of heat and electricity, although not good as copper. So aluminum is also a good conductor of heat and electricity, because we have seen here that most of the non-ferrous metals, they are good thermal and electrical conductor, or they have good thermal or electrical conductivity. So in that case, aluminum also has a good heat and electricity conducting property. Then it possesses high ductility, that means it can be drawn into thin wires. Ductility means wires, thin wires. And lightweight, so widely used in aircraft industry. So as we have discussed earlier, non-ferrous metals are very lightweight, so they are used widely in aircraft industries. Next, needs frequent annealing if cold work, since it becomes hard after cold working. So it needs frequent annealing. Annealing is a heat treatment process. We'll look at it into our unit number 6. So as of now, just remember that aluminum requires frequent annealing if cold work. That means if it is worked in normal temperature, because it becomes hard after cold working. So just remember this. What is annealing? What is how it affects cold working? That we will study in detail in unit number 6. Next is, in view of its ductility and malleability. Malleability means thin sheet. So in case of ductility and malleability, it has replaced copper in electrical transmission and appliances to some extent. So we have already seen that copper wires are used in most of the electrical appliances, but due to better ductility and malleability properties of aluminium, they are also used in these electrical appliances. Next is, it is used in manufacturing of household utensils, including pressure cookers. So this is very common uses of aluminium, and everyone of us have seen aluminium utensils in our home. And next is, it is used for aircraft bodies, drink cans, high tension wires. So this is also something that we are already know or already seen, but never knew that it was aluminium. So aircraft bodies made of aluminum. Drinking cans is nothing but your cold drink cans. And high tension wire, these high tension wires, they are used in your electrical poles or electricity transmission poles. There we have seen these high tension wires. Next is copper. So copper is also very commonly used non-ferrous metal. Let's look at its properties and applications. First property is, it has high thermal conductivity. So it is used in heat exchanger, heating vessels, appliances, and other 32 manufacturing processes. So just remember that we have seen these water heaters in our home. The main element that is used in water heaters for heat conduction or heat transfer is your copper. So we have copper coils like this in our home. So the best example is, you must have seen this. This is your water heater in home, and this water heater is when connected to you have this switch. So these coils are nothing but your copper coils. See, next is high electrical conductivity. So we have discussed here also that how copper is mostly used in electrical conductivity. It means most of the wires that we see in electrical appliances are having the copper wires, because they have good ductility. So having good ductility leads to getting or having a thin wires out of copper metal. So it is used as an electrical conductor in various shapes and forms for various appliances. Next is good corrosion resistance. So as we know, most of the non-ferrous metals are good corrosion resistance, and copper is a good example of a non-ferrous metal, because it also has a very good corrosion resistance and provides a coating on steel prior to nickel chroming plating. Next is high ductility. So due to this property only, it is used in electrical appliances as well as in heating appliances, because having high ductility leads to making a very thin copper wires, which are majorly used in electrical appliances as well as heating appliances. Next is lead. So this is a very heavy metal. So we have already seen the arbitrary classification in heavy metals: copper, zinc, lead. So lead is a heavy non-ferrous metal. Okay, so it is a heavy metal. It is dull grey in color and is flexible at room temp. Lead is nothing but, you have already seen the pencils that you used to use. The pencils have this lead at their top. Okay, this lead, it is a resistance to corrosion. It has a good resistance to corrosion. Next, it is soft, heavy, malleable, and can be easily worked and shaped. So it is easy to machine the lead, so it can be formed into various shapes and sizes. Next is, lead is utilized as alloying element in producing solders and plumbers solders. So we have already, most of us have seen the solder guns used in electrical appliance or electrical repairing work. These solder guns have the alloy of lead and tin, which is used for the soldering. Next is, it is used in a alloy having with brass as well as steel to improve their machinability. So lead is introduced in brass and as well as steel to improve its machinability. Okay. Next, this machinability is very good for in case of lead due to these properties, that is soft, heavy, and malleability. It is used in manufacturing of water pipes, coating for electrical cables, acid tanks, and roof covering. So this is also a major application of lead. Next is, apart from this application, there are some disadvantages of lead, and major one is that it has a toxicity, that it is toxic in nature. Next is, the solder is an alloy of steel and lead. So I already said that soldering iron uses the solder, which is alloy of lead and tin containing small amount of antimony and silver. The solder are mainly used in soldering electronic circuits due to their low melting point. So these lead as well as tin alloy, that is solder, they have a very low melting point. That's why they are used in soldering electronic circuits. Soldering is nothing but when you are connecting any two electrical appliances or any two electrical points appliances or their points using solders, which are nothing but alloys of lead and tin. Next is zinc. Zinc is also one of the common non-ferrous metal. Let's look at its properties and application. So just like copper and aluminium, zinc is also high corrosion resistance, and most of the elements are used to have, or they have zinc coating for the corrosion resistance property, high fluidity and low melting point. So most suitable metal for pressure die casting generally in the form of alloys. Zinc with the form of any alloy used in pressure die casting. This is nothing but with the help of pressure die or with the help of pressure mold, various shapes or various molds are prepared to get the desired product. Next is, when zinc is rolled into sheets, that is zinc is having high malleability. Zinc is utilized for roof covering and for providing damp proof non-corrosive lining to containers. So in most of the containers, zinc is used for providing a non-corrosive lining of containers because of its high corrosion resistance. Next, the galvanized wire, nails, etc. are produced by galvanizing technique, and zinc is used in the manufacturing of brasses. So galvanizing is nothing but providing a zinc coating to the various metals in order to increase their corrosive resistance, and zinc is also used in the manufacturing of brasses. We will be looking into brass, bronze, etc. and in detail in our coming lecture. Next is tin. Symbol is SN. Let's look at their properties and uses. As with many metals, pure tin is weak or too weak to be used alone for most of the mechanical applications. So tin cannot be used or should not be used alone as a pure metal. It should be used along with some other metals forming an alloy. So it is often alloyed with elements such as copper, antimony, lead, aluminum, zinc to improve its mechanical properties. It is commonly used as a coating for other metals such as tin cans, copper utensils, etc. Other applications include die casting alloys, pewter, chemicals, bronze, bearing alloys, and solder. So I have already seen that lead and tin are used in solder guns. Similarly, there are different other applications for your tin. Thank you. I hope you understood various non-ferrous metals, their properties and their application. In our coming lecture, we will be looking at various non-ferrous metal alloys and their application.